Hello, I am ZHUZHI. I'm happy to present our paper about the impact of softness on users' perception of curvature for future soft curvature-changing UIs. The perception of the curvature of soft surfaces come into play with novel interaction. In HCI, soft curved UIs have been explored. For example, surrounding daily objects can provide haptic feedback in VR. For instance, here, taking an airplane payload as a donut, designers can now customize UI's softness and curvature to add haptic feedback and interactivity to 3D printed objects. Soft curvature-changing UIs can provide users haptic feedback with curvature-based shape display to ensure the efficiency of haptic feedback of soft curved UIs. User perception is now a bottleneck. HCI designers need to know users' ability to perceive the curvature of a soft UI. In order to know users' ability to perceive the curvature of a soft UI, we addressed two research questions. The first question is, how well can users perceive the curvature of a soft object? And the second question is, does the softness impact the perception of the curvature? To address these research questions, we conducted an experiment to study users' curvature perception, precision, and accuracy in different softness conditions. Before we started our experiment, we registered it in Open Science Framework. Our independent variables included 4 different levels of softnesses and 3 different levels of curvatures. I present here the 4 levels of softnesses that we studied. Below each softness is a daily object having similar softness. The first level was designed to be softer than our index finger pad, which is similar to a gummy candy. The second level was designed to be as soft as our index finger pad, which is similar to a gel shoe insole. The third is harder than our index finger pad, which is similar to a rubber band. The last level is rigid, which is similar to a shoe heel. Here is a 3D model of a stimulus. Participants touched and explored the top surface. The top surface had a different radius of curvature. To investigate user perceptual sensitivity over a broad range of UI curvatures, we used 3 different curvatures as reference: very curved, medium curved, and little curved. For each curvature reference, participants were presented with 6 comparison stimuli, whose curvature were around this reference. Our experiment used a standard to alternative forced choice, a procedure. That is, in each trial, we presented participants with 1 reference stimulus and 1 random comparison stimulus from respective group. Participants touched and explored each stimulus successfully. Then, the participant had to indicate which of the 2 presented stimuli felt more curved. Here is a video presenting a participant exploring 2 stimuli in 1 trial in the experiment. The experimenter presented the first stimuli to her and told her to start the exploration. She touched and explored the first stimulus, and then signaled the experimenter that she completed the exploration. Then the experimenter switched the stimuli and asked her to explore the second one. Once she is done exploring the second one, she answered which one is curvier. With the participant's answer, we can estimate the precision of participants' curvature perception and accuracy in different curvature and softness conditions. We measured the precision through the just notable difference, shorted as GND, and the accuracy through the point of subjective equality, shorted as PSE. I will now present some major findings of our experiment, starting with the precision. Here is the result about participant curvature perception precision. The smaller GND means better precision. It is presented in this figure as the x-axis in the unit of millimeters. We found that in the most curved condition, participants perceived with similar precision in all 4 softness conditions. In middle curved condition, participants perceived with similar precision into softest conditions. Participants also perceived with similar precision in the hardest conditions. Comparing them, we found that participants perceived with better precision in the 2 hardest conditions than in the 2 softest conditions. In the flattest condition, participants generally perceive with greater precision in the harder conditions. We also found that in each softness condition, as the stimuli becomes lighter, participant GND increased, which means the precision decreased. Here is the result of parallel fit of GND in different softness conditions. Points in this plot are data that we measured. We slightly jittered the point horizontally to avoid overlap. The curves are the fitted results. The exponent of fitting result indicates how rapidly participant GND increase as the surface becomes flat. Larger exponent indicates a more rapid increase of GND. We can see that the exponent decreases from 1.76 to 1.45 as the stimuli becomes less soft, that is, from short 0010 to rigid. In addition, all exponents are larger than 1. This suggests that with a softer material, the difference in precision under different softness conditions may be larger as the surface becomes flat. In summary, the average precision was 0.63 mm for a 10 mm curvature, between 2.03 mm for more rigid surfaces and 2.68 mm for softer surfaces for a 20 mm curvature, and for a 40 mm curvature, between 4.32 mm for more rigid surfaces and 8.61 mm for softer surfaces. Now, let's see together participant perception accuracy. Here is the result of participant perception accuracy in different curvature and softness conditions. It's presented in the figure as the x-axis in the unit of millimeters. We found that in each curvature condition, participants had similar accuracy in each softness condition. From the pairwise difference of accuracy between each softness pair, we can see that there's no clear difference between different softness conditions as all error bars for 0. We also found that participants tended to be less accurate when exploring less curved surfaces. In summary, the average accuracy was 0.31 mm for a 10 mm curvature, 0.9 mm for a 20 mm curvature, and 2.67 mm for a 40 mm curvature. Based on our experiment results, we provided some guidelines for the future design of curvature and softness-changing UX. First, when curvature precision is crucial, and it's not possible to use very curved UX. For instance, on a large-scale soft display such as this one, the curvature is used as a relative display of the curvature of a planet, here, the Earth. Users should be able to precisely perceive rather large curvature radiuses. In this case, designers should focus on or change the stiffness to more rigid material, for example, around short A30. When designers need to build UX with a larger range of curvature, for example, for a toolkit such as this one, enabling a wider range of curvatures for soft shape-changing interfaces. In this case, designers also should focus on or change the stiffness to more rigid material. For example, designers can add a layer of jamming over an air chamber to create a softness-changing and curvature-changing surface. As shown in this video, before the air of the jamming layer being vacuumed out, the jamming layer can be pushed to be curved when pressurizing the air chamber underneath it. In this state, the surface where user touch is soft, and the air inside the jamming layer can be vacuumed out to stiffen the surface from soft to much more rigid. This can help to provide user with better curvature perception precision. Another guideline for building precise soft curved UIs is to focus on very curved UIs, that is, radius around 10 mm, where any softness can provide users with precise haptic curvature information. Similar to precision, designers should also focus on building very curved UIs when accuracy is important, as they can also provide users with accurate haptic curvature information with any softness. For example, users can perceive S3 if the number of messages received increased when they are in the meeting through the curvature of a soft watch capable of morphing into a very curved shape to timely notify precisely and accurately through curvature. Thank you for your attention. I will be happy to answer any questions.